So this is the second video in my set of videos for lightning mental mathematics and lightning mental calculating. So we'll just start now with lightning mental differences. Well, of course, this is how you do mental mathematics without looking at anything. High number mental mathematics, such as like 3-digit numbers times other 3-digit numbers and beyond, you know? It just depends on your computation time. But the more you practice it, the more you can master it over time to have a faster mental computation time. So anyway, so differences are the things that are in between subtractions, right? So we have, when you get good at this, you will be able to do things like this. 9, 8, 2, or 9, 8, 7, 2, 4, 5, 6, 1, 2, and then 0. Plus 8, 1, 6, 2, 9, 3, 4, 2, 7, 1, right? So normally, you know, people are taught the very ancient and archaic way of doing things in the U.S. mathematical education system, They teach you to like do all this stupid stuff where, you know, you have to borrow from this side and carry over and all this stuff, and then you cross them out and then you subtract it and all that, right? Well, this is a very ancient and archaic way of doing things. This is basically what they teach to the general population. We don't know why, but they do. So we'll just start with some very basic numbers, some very simple numbers. And the more you practice this, the more you master it. But please see my other videos that I have made available for free to accompany a free handwritten book that I have digitized into a PDF. And what you would do is you would master each thing as you go until you become a master of lightning mental arithmetic. And then after that, you can become a master of lightning mental exponents and exponent roots. And you can become a master of lightning mental algebra. So the more you practice and the more you master it, the better your life will become, actually, the more organized it will be. It just depends on how you apply it. It does help you in day-to-day life in many different ways. So we'll just do like, I don't know, 25 minus, I don't know, 18, right? Very basic number, right? 2-digit numbers, and then we have the line here, and then the operator, and then the equal sign. So really, this is like a minuend, right? And then this is like a subtrahend. And then this is like the equals or equality, right? And this is the operator or the operation. So technically, This is also a minuend, and this is also a subtrahend. It just depends on how many of these columns and rows that you have. But here, we're only doing two factors, right? Factor 1 and factor 2. So factor 1 is a two-digit number, or a two-digit number, and factor 2 is another two-digit number, right? But of course, I mean, it could be any combination of numbers. So the way that you would do it is you'd actually take the lower number and you would count up. So you say, well, how many numbers are there? How many whole solid numbers are there between 18 and the next base number, which would be 20, right? So how many from 18 to 20? Well, there are two. There are two whole solid numbers. Okay? So now we're at 20. 20 is the base number, right? Now there are 5 left over to 25. So you add 2 to the 5, and that's 7. So you know that 25 minus 18 is 7. Okay? So what I'm doing here is I'm counting upwards. I'm not using subtraction, and I'm not doing this anymore, right? I'm not saying, oh, okay, well, this is a smaller number, and I can't take away from that, so I'm going to have to cross this out, make it a 15, and say, oh, 8, 9, 10, 11, 12, 13, 14, 15, which is a 7, and then the 1 minus the 1 is a 0, right? Okay? I'm not doing that anymore. What I'm doing is I'm counting upwards, and I'm doing it instantly in my mind. I'm actually able to get this within a millisecond, okay? And if I take it further to a 3-digit number, or a 4-digit number, or even a 10-digit number, I can do the whole thing in my head within 30 seconds or less, okay? So let's try it again with a 3-digit number, right? I don't know, 628 or something. So again, we start with the lower term, the lower number, right? Which would be the 486. So how many do I need to count to get to 90? 4. Now how many left over do I need to get to 500? That's 10. So now I have 14 to 500. And then I have 114 to 600. Now I have 114 plus 28. So that's 134 plus 8. 134 and then 142, right? So it should be 142. So now if we take 628, right, and we do 486, right? You have to cross over and all that stuff, make that a 12, cross it out, make it a, oh no, you can leave it as a 12. And then you do 6, 7, 8, that's 2. And then 8 to the 12, that's 4. And then 4 minus 5 is 1, 142. So that's exactly right, but so is this. And I did that within a split second. So let's try another one. Let's try one with a 4-digit number minus a 4-digit number. Let's do like 9,621 minus 6,432 or something, right? Okay. So remember, we have to take the lower number here. So we think, well, how many do I have to count to get to the 40? That's 8. So now I'm at 40. How many is left over to the next base 100, right? 60. So 68 to the 500, okay? 68 to the 500. Now I'm at 6,500. Okay. 500 to 7,000. So 568. And now we're at the 7,000, right? So 568. 2,568. 2,568 plus the 621. 2,568. So 3,001.